Hi all. This video is going to be about a paper titled Beyond Neural Scaling Laws, Beating Power Law Scaling via Data Pruning. So the name itself suggests that what this paper is going to be about. This paper is one of the best paper in NIPS 22. So what this paper says about. So we know that the success of deep learning lies on the increasing the model size and increasing the data size. For example, a large language model like GPT. But unfortunately, it ends up in scaling laws where there is a power law relationship between the reductions in error with respect to the increase in training data size and model size. So this results in an enormous amount of cost in both in computing and energy. So how do we break down this power law model into an exponential scaling loss? So this can be achieved, this paper say, through a high quality data pruning metrics. What does this pruning metric it means is we have a large amount of data. We try to identify only the essential data and putting that essential data into training the models. So this says that this if by doing this power law can be break down into an exponential scaling laws. So they tried it empirically on different data sets like CFAR, ImageNet, and RIM. They found that this is giving a promising result and could able to achieve what they are aimed for to beat the power law model. And they also benchmark these studies on 10 different pruning metrics on only one data set like ImageNet. But unfortunately, most of these pruning metrics are not very efficient or poorly scaling to the image data net, but some of them are best for making best things for pruning the data sets into a high quality data, breaking the power law model, but they are very computationally intensive things. So what this paper effectively aimed is to build a very simple, cheap, and scalable. Instead of supervising pruning metric, they entered into an unsupervised pruning metrics, and they showed that it has a comparable performance with the best supervised metrics. They have achieved through statistical learning techniques to build a cheap, a scalable pruning metrics, and they could able to evaluate on an empirical data set like ImageNet and prove that it is promising directions to beat the power law and end up in a exponentially scaling loss. And through this they says that in future we can able to build a deep learning of with a reasonable reduced computational cost. Hopefully we'll see about what are the details, how they build these theoretical studies and how they empirically evaluate these theoretical studies on different data sets, and how they ended up in building an scalable efficient self-supervised pruning metrics in the next one or two videos. Thank you.